Hi, welcome to a tutorial on Git. Git is a distributed version control system that's used to manage text and most typically code. Now this tutorial is in a small series of tutorials on the introduction to project management for engineering, and this is because doing version control on software is fundamentally related to project management, where the project contains some code which you're managing, and its versions and its development over time. Now, the intended audience for this are the people who never used Git or did any project management, and they're starting to do their first project for the first time. So something like a project course at a university, but whatever the use case may be, and this is for the sort of smaller projects initially. Okay. Now, why am I tying Git to project management, and why am I even doing a tutorial on Git when there's so many videos explaining Git out there already? Well, this is because I want to focus on more of like what's the purpose of this, why do you want to use it, how it helps you achieve the goals you already have if you're starting out with a project. And I think you need to know Git before you start doing your project and incorporate the structures and the way Git functions into your project planning, and to basically leverage it for project management fully, because that's the point. I mean, if it's of course a very nice tool to do all these things, but that's what we sort of need to see the forest from the trees, and I don't think this is what's covered very often. Okay, so the best way to sell you the idea of why you should use Git or any really version control system, management system, is to just think of what would happen if you didn't use it at all in your project. Okay, so let's say that you and your group of friends want to start working on a project, and then the project requires you to have some code. Now you start off with some initial common code that you maybe wrote on the first day you met. Then you all go home, and you want to work on the parts that you've agreed upon, that okay, I'll do this, you'll do that, and so on. So you all have the same starting point. Okay, and then I write my own sort of little piece of code there. You write your piece of code, they write their piece of code, and they write their piece of code. And now what we want to have is a new common ground where every one of these changes has been integrated, right? Because I don't know what they did over here. I don't know what they did over here. That's on their laptops, and now what? The first thing that would come to mind is, hey, can you please make a zip or a tarball or something of your code over here, and then send it over to me so that I can review it, and I'll send you my what I did so that you can see, does this break anything, how do we integrate it, and so on. But then everyone has to do this for everyone else, of course, because how else? Well, we all know what we all did. So then, as you can see, these number of lines, it's completely unmanageable. So then what you would do, I assume, is instead of all of this, you would all sit down at a table, stare at the single computer screen where you had all of these versions, and then you would together hammer it out. So you and me, we sit down and we fix the versions of our own code. Then the lucky person leaves and the integration comes like this from the next person, and so on and so forth. At some point, we all sit down to see whether the results make sense or not. Now, if you were thinking as you were watching this, oh my God, please stop, just show me a better way, then I made my point clear, because that's exactly what Git is trying to resolve. This not having this exact situation. So it's basically an automated. It tries to automate as much of this process as possible. So for example, if I wrote something in file called A, and this person only wrote something in a different file that's named B, so they're different files, then there are no conflicts, because they're not even in the same file, right? So then you would expect, if we have some sort of automated version control system, that the program would tell you this is okay because there are no conflicts. But what if instead we both edited file A, and now this is like A prime and A prime prime? What do you think, should happen now? Well, I guess then we would go and say, okay, this upper portion of the file, that's the same, so we don't touch that. No one edited that. Then in some middle portion at line 33, I wrote this, and my colleague over here, at line 33, wrote something different. Now I would want my software management tool to come in and say, see, right here at this line 33, both of you did something, this something is not the same, then you need to decide what should be on line 33. It could be a third thing, because these two, we both want our line of code to exist. We changed it somehow from what it was originally, and now we need to sit down, figure out a solution that could be something else, more lines that fixes the issue, fixes the integration. And then let's say, of course, down in the bottom of this file, there's again nothing happening. Or maybe I left it the same, and my colleague here at the end of the file, after that, added more stuff. Now this doesn't bother anything because it's more stuff. It's not in conflict with what I have here, which is nothing. So we just, I want my control versioning thing to understand this and just keep these changes. But again, inform me about what's going on right here, where we changed the same line. Now you might be asking yourself myriad of things like, how does this, what changes depending on the language we use and so on. And here's how does this work? And here's my the way I would explain this is as follows. So Git is not a magic bullet that resolves the issues of what happens in a particular piece of software. What can you or can't you do with an API? If the language you're writing this in is statically typed, then the inputs of a function, if you change what are the inputs to a function, it's now a different function, or the types of what the inputs are, and then that would be a different function. You would handle it according to that. In Python, you don't have this because it's dynamically typed. So if you change the data types of inputs to a certain function, that's still valid. I just might have changed, I might have not even changed anything how the function is used. Even depending on the situation, maybe I have an if inside the function, that if you pass this, I'll do that, and so on. And there's no way that a versioning control system knows any of this. Okay, that doesn't exist. It can tell you the sort of things I showed you here and offer you tools for you to do more, but it just sort of enumerates sort of what's been going on in a way that's usable for you. But as you also saw with the A and the B file, if you're writing in different files, no sane manager will do anything. That's what Git does. So if you want to have less conflicts, this is why I'm tying this in with project management overall. You can just say, hey, we want to work on these two separate things. I'll do it in this file, you do it in this file. Then we don't have to worry about our code stepping on each other's toes. And furthermore, before you even start working on your thing, if you both need to interface with some other part of the code, you can decide, in your meeting or discussing this via email or whatever, hey, I want this functionality from this part of the code, you are using it as well, what do you need? Then they say, okay, I need this and that. And then you decide on the API, the application programming interface. Okay, so I'll need this from that function. We might write it 3 weeks from now, whatever, but just let's have an expectation for what this piece of code should do, so that we both can use it and like sort of expect what's going to happen from this. So this is the sort of things, these are the sort of things that you will need to do regardless of Git. Okay, so that's the point I'm driving home. So the planning and the code management is a wider story than just Git. Git is a tool that we use to help us do these things. Okay, so now I'm gonna actually tell you like a little bit about how Git works and point you to tutorials which are much more with better drawing and so on that will explain you explain the details to you. Okay, so well, first sort of the first thing we'll tackle is like the graphical representation that I'm going to use for this. So if we have a line, I will say that well, it could be a straight line to make this simpler. So just have a straight line. This line, the sort of represents the code in time. So here at the beginning, with like t0 or something, you have nothing. There's no code exists. Then you add some sort of a change here, and you label it with some sort of a name. So let's just say I don't know, first thing. Then down the line you do something else, and now you say this is called added CV for computer vision version 0.1 or something like this. Then down the line you do some more changes and you enumerate them like so. Okay, so we basically just have the progress of the code base in time, where we mark at arbitrary points really, okay, this is a version of the code at this time instance. Now these small things are called commits in the language of Git. Would be a commit. And then the first thing that we can do with this is we can say, okay, if I'm now on this commit, but I didn't actually like what I wrote, I want to do it a different way, I can go back to this commit and start all over. So this is the sort of one type of thing that you can do already with a single line to code in time. And that might be useful. You might just tinker with something experimentally and decide, okay, this didn't really work out, I give up, I just go back to the previous point. Why would you want to use Git for this? Just for that. It's because you can change like 16 files, to see if something works. It could be like 3 lines in every file. You will forget this, okay? You will forget this, and then you won't know what to do. Now you could, I don't know, copy everything into a different file, play around with it there, but it's easier to just, do it within the Git workflow, because there will be other things that are kind of impossible to do without it. So, let's just call this a W for Git already. And I'll get you how to do this specifically. I just want to give you the high level overview. Okay, well, now let's start with the clean thing again. Okay, so let's say again, this is your project in time, roughly, where the time doesn't really exist, but it's in these things called commits. Now, obviously at this point, I think it's obvious at this point already, the more commits you have for even smaller things, but it makes some sort of sense the more fidelity you have on what to do. Okay, so anyway, let's say I'm at this point in the project, and let's like call this, I don't know, basic, no, that's my favorite way to say it is minimum viable product. Okay, so there are some moving parts here, whatever it is, and then it sort of works. Now at this point you get your friend who's been studying again like computer vision or something, and what he'll do is he'll copy the project from this commit and he'll create his own version. Let's do it that way. And then in this version they will develop in commits again in stages a computer vision solution for something. So let's say, you know, a roboticist, let's say at this point you had a predefined point for something that the robot should pick up on the table. Now you want to make this thing like variable, and what this person here is doing, they're writing the computer vision for that. So the idea there is there will be a function that instead of like a predefined list of points on the table where a single thing is, there will be a function that you call that will spit out these coordinates based on some camera input or whatever. Now simultaneously, as this is going on, what you do is you take the same copy of this code again, and you do some commits here that, I mean, it could be a different number of commits, differently spaced, whatever. And here you try to make the functionality for the robot to be able to pick up the thing at different spots on the table and have everything working, basically. So now what? Now you want to do what's called you're done, let's say, with your part, and you want to do what's called a merge, where you put all of these updates back on the main line, which we call main. So now this whole thing, one copy, let's say, one version of the code is called a branch. So this is a branch. Blue branch. We have the green branch, and that's called, I don't know, the CV branch. You can name them however you want, obviously. And this is, I don't know, Mava branch. So what I'm doing at this point right here is I'm merging the move branch or back into main. Okay, and then what we want, at some point more computer vision development happens, and now we want to get this merged at this point into our project. Now there are now doing this part right here, or this merge right here, that's super easy. Why? Because the main branch didn't change at all, and I could just say, okay, apply these commits over here as if they were happening on this branch. Easy money. So then we're here, we're happy. Now, however, we have a problem because these updates need to be put not here, but here after the main branch has changed. So this merge will be a bit more involved. Okay. Now again, if half of this development here happened in a separate file, then of course that would just be appended basically to the project. But if you have a file that's like, I don't know, the control file, then all of these different states would be enumerated by Git, and then you would decide what happens here. Right, so if this part does not interact with anything, then we just leave it, and that's fine. But if there's a conflict over here, then Git would tell you in a pattern like this in the code, some comments there, hey, please change these parts, and then you do that, and then you fix the issue. Okay. So you fix the issue, and then you make a new commit where you say something like merge resolved, because you can name the commits as well with like messages that explain what you did. Okay, so this is like roughly what would happen. That's the idea. Now, if you have a real project, there would be, I don't know, 10 branches. The pushes to main would happen relatively constantly. One thing that you might also want to do is, like, you at this point you're aware that main changed, so maybe you want to apply the changes that happen to main over here before you update the main branch. Yeah, but what you want to do, I mean, you should have an idea of what you want to do and then basically see how to do it in Git. But this is the types of things that Git does. Okay, so now that we have a high level overview of sort of what's the point of this, and I'm again not giving you the exact technical details, I just want to showcase the type of thing that's being done so that you know what to Google. If you know what to Google, that's it, you're set. I just want to give you the option of give you the ability basically to Google what to have the idea that you are going to Google. Okay, now that we've covered the theoretical part, let's actually hammer out some commands just so that you can have the minimum command starter pack so that you can go from there. So I'm in the GitLab of the tutorials with the text. Now I also have the videos here via GitLFS. That's something I will mention later. For now, what you need to know is once you find the page, GitHub or GitLab doesn't really matter. They function the same way. If you want to clone or download this repository, you go and you select one of these options. If you have the SSH keys configured, I will mention what that is later on. That just means you don't have to type in your username and password. Use that, otherwise use this. And of course, if something is public, it won't even ask you to log in, but very often you work with a private repository and then this is relevant. Anyway, you select some of this stuff, you go to the folder where you want to download this, and then you do a git clone. Now I won't do it because I already have the repo here. Now I can first check on which branch I am. There's only one branch that's called master. I've recently, if I go to log, I saw that I made the last commit like 5 minutes ago. So I know that whatever I do going forward will be clean. Anyway, let's now edit a video so that we have something to show. This is the README page where I sort of have everything that the tutorials cover. So I will just add, because I don't have this written yet, project management, management. I hope that's how you actually spell it. All right, and then something, what's introduction, and we also have Git tutorial. Okay, now I've made this change. Now I need to tell Git that I've made the change to this file. Now typically what I would do is I would do git add dot. The dot, if you know from the Linux tutorial, it's a relative path denoting this current directory. And if you give git with the git add directory, by default it will be recursive. So I will do that. I will just add the file because I have the videos. I don't want to wait for something as I'm recording this video. So let's just add that. Now I create my commit. And with the dash, I can type in a message. There's other ways to do that. I try to have small commits so that I can tweak them around. Like I said, the more commits you have, the more fidelity there is in what you can tell Git to do. There's this tendency people have to create one huge commit where they've resolved everything, but that's exactly, you're dodging the exact part in which Git is supposed to help you if you do this. So small changes that
yeah, I mean, they could even be breaking your code. Just make more commits, okay? Nothing, there's no cost to having more commits. Added tutorials, added project management to README. Okay, and now it says one file is changed and there were only insertions. If I deleted something in the file, then it would be deletions as well. Okay, and now to actually update this change, I do a git push. So now what will happen is, and this is how git works. Now this change, that's on the copy of the repository on my computer will go to the repository that's on the remote computer. So there's a server, and the server keeps track of everything. I mean, you have to push to it to actually update it, but now as you can see, there's nothing here in the end. If I refresh, this is rendering the markdown. Now we have the changes put in here. Okay, so then when you work with other people, you all push to this remote server, and then they pull from this server. So if I was someone else now, I would need to do a git pull to get this update from the remote server. So via the remote server, that's how we synchronize. That's the point here. Now if I had some changes that I wanted to discard, I would do, well, discard, like cut them out, go back to the last commit. Then I would do a git stash. So if I go into the README, I do this, and now I say git stash. It's going to save the working index directory, blah blah. If I now go to the README, this line is here now because I've reverted the change. And the great thing with this is if you change like 16 files to try something out, then with the git stash you can have it. Now you can undo the git stash by git stash pop, right? Let's see. Yeah, exactly. So git stash pop, but in fact I want this to remain. Okay. There's also git revert for this, but I typically always use stash and then never pop it out. I don't know if that's the best practice, but it typically works. Okay, so now let's create a new branch. We do that with git branch, and they're always called something, I mean always, very often they're called something like experimental. And now if I list where I am, okay, so now we have the experimental branch that exists here. Now I go and I check out, or what's the better way, switch. It's either switch or checkout. Let's see, man git switch branches. Well, that's exactly what I want. Git switch experimental. And now if I see where I am in the experimental branch. Okay, so now let's say I go to project management. I have some notes here. Now, I mean, none of this is code. Okay, this is open already somewhere else. Ah, I know where it's open. This is this video. Okay, whatever. I make some. I will delete this line and I will instead put something different. This will be covered in the Git tutorial. Okay, so it's the same line. Now I go back. Now I add this change. Again, I could add the dot, but there's a video here which I don't want to be bothered with right now. Commit test. This is not a very good message, but let's keep the ball rolling. And now it says, oh no, there's the current branch experimental has no upstream branch. So this means that on the remote server, we didn't set up the experimental branch, which means we have to do it now, basically. And Git is very phenomenal, probably my favorite sort of error messages out of any program, because it tells you this immediately to push. the current branch and set the remote as upstream, use this. Great, I don't even need to type anything out. That's exactly what I want to do. So now it's gonna do some things. There we go. We've set up the this branch on the remote. Excellent. Now if I go here and I refresh, I can see that there's now a new branch that wasn't here before. Okay. With this out of the way, we can let's do a switch back to main or master. What is it called? Yeah, git switch master. And if I do a git pull, now nothing is to be updated here on the main branch, and that's because we've changed things in the experimental branch. Okay, but now I want to merge the changes from this other branch into my branch over here. So what I can do is I think I can even do this with I should be able to pull from the experimental branch, but I typically prefer using the merge command. Git merge experimental. Okay. So now it detected that there's no conflicts and it can just fast forward the commits. So this is if you go back in the video, there were two lines where two different branches. One was this, one was that. The first one we can just merge directly onto the master branch. Okay, and now with this I can add everything and say git commit merged. Yeah, so now I'm basically just pushing this commit that nothing. I didn't do anything additional, so I don't need the add, but I needed to push so that this update on the master branch actually happens. Now for homework, what I want you to do is I want you to set up multiple branches, do various different commits, do something crazy and potentially, something that would be considered stupid for normal practice, and then use the Git tools to resolve the conflicts that you will have. Now in this simple example, there was no conflict, and most of the time this is sort of everything you need to use Git. But its power comes from how it handles the different merge issues and so on. So what I want to, there are a few tools that you can use for that I want to showcase now. Is git diff readme, or does it? I first have to specify the branch. So the diff will tell me the differences that happen between different files. Wait, let me actually check. Okay, commit, and then I give the path. Okay, then git diff, and let's say this, and I want to check the project management 01 file. So now it's going to say that at line 47 this was deleted and this was added. If you want a nicer view, then you can use git diff diff tool for this, and they set, so now it's gonna open the differences in a text editor. I've set it to Vim because I use Vim for everything, of course. Now you can see that everything that's the same has been stored up here, and the differences are highlighted. So when you have a merge, this view is incredibly powerful and helpful. Actually do things. I should have put my face like so. Yeah, and then you change what has to change for the conflicts to be resolved, and yeah, this is the easiest way to do it. And you can of course add multiple different files, then compare all of them and so on. I know that people typically use Microsoft Studio Code for stuff like this, and yeah, it has Microsoft Studio Code has the equivalent of diff tool that you saw in Vim, and there's some setup for this. Okay. I want to cover some goodies that are maybe esoteric on the surface, but are actually very helpful. Number one is there's a get ignore file, and in the get ignore file you can tell get which files to ignore. Now I have some presentations in LaTeX, so I tell it, okay, these random files that well, they're not random, but these non-important to me files that LaTeX generates, I don't care about them, don't track that. Because they're gonna change all the time, and I will compile the tech into PDF, and I don't need the previous logs for that, so just don't keep track of this. If you have some very large files, like here in the video, I have some videos. Maybe I should go to something like Python. As you can see, they're like very big. Typically, Git works up to 50 megabytes, so this is no bueno. It's not gonna work. So if you have like, I mean, it will break your Git. I think GitHub has a limitation of like 50 megabytes. There's something called Git LFS that you can use for this. But I mean, honestly, if you have something like a dataset, you can just download the dataset after you've dealt with your repository, and then just ignore the folder with the dataset. That's probably what's good enough for you 99% of the time. Use the cloud storage for cloud storage purposes. Then we have this thing of logging it with SSH keys. And yeah, the get LFS. Okay, I mentioned this. Okay, so these are the. I will mention how to log in with SSH keys in a bit. This will be a part of the resources that I want to show you for how to learn the rest of Git, the things that I've skipped over here. So I showed you just the most basic thing, the tip of the iceberg. For this, use the man Git tutorial, which is the Git tutorial. There's two of them. Then there's Git Everyday and Git Workflows. By the way, if you're not on Linux, if you search man Git tutorial in Google, you will get the man page on in the web. Okay, so this is the same page as I'm going to open here. I definitely recommend going over Git tutorial. There's a lot of things that I skipped out on, like how do you sort of have your default logins set. So that's what you put your name or your email here, so that when you need to authenticate, you can use that. Now for the SSH generation, I don't know if that's covered here. It's not covered here. Okay. So SSH is, if you saw it's the remote login procedure. It has some encryption, so on. I won't talk to you about encryption and security. If you want to know more about that, read up on that yourself. This is what you will need to generate your own key. Once you have your key, it will be stored in .ssh. This is your private key, this is your public key. There's two keys, signatures, something, encryption, something, doesn't matter. Okay, this is what you give to different services that you want to log into. This is what you will use to encrypt stuff between the communication, and this is what you use to decrypt. That you never share this one ever with anyone ever. Okay, you just share the public one. And it's typically called ID RSA because RSA is the default protocol, if I remember this right. Okay, and then how you would set this up in GitLab, you would go to, I'm not signed in right now. You go to your settings, preferences, something like this, and then you go to SSH keys, and you can put your key right here. Now I know that this is the public key, so you can't do anything with this if you don't have my private key. Yeah, anyway, you set it up here, and then you can do the cloning with, if you clone a repository with SSH, then you don't need to input your email and password every time once you do your push or pull or something. Anyway, let's keep going with the Git tutorial. There are definitely some nice commands. Yeah, so the log I think I did show, but there's a lot of options you can pass to things like log that will get you sort of a nicer thing. There's even a graphical interface that I almost certainly will never use. Wait, okay, I should have run that over here. Yeah, so now we can get like a graphical representation of the commits and the different files, and I don't know what. So if you're into that, that's cool. Then yeah, this will sort of cover the basics. Then for the, I think you actually need Git. Yeah, you do need to go to Git tutorial 2, and here will be some examples of how you do things. How do you set the offer and so on. And and the sort of the very similar thing is covered in Git Everyday, but Git Everyday really covers everything more than just the tutorial. So you can cover this for the what's said for the individual developer. You can tag some things that's useful, and as you can see here, there's a whole bunch of commands that I run, and there's an explanation for them. So to be inspired with how you want to manage your project, look into this, see the different options that exist, and then put in your project plan and everything else that you have, you put the how you're going to manage the code into that before you start coding. I think that's the you will make your life very easy with that. Now below there are after the participant, the integrator is there's different roles of who in the very big projects that use Git. You need different roles where there's maintainers, developers, and so on. So you don't need all of this. Maybe up to integrator it's still good, but repository administration you certainly don't need to know. Other than that, of course, I need to give you a whole book, an open source book on Git that will cover more things than even in the tutorials. If you're the type of person who likes reading a book where everything is nicely explained. Now, after that, there's some cheat sheets. I think these are even probably something relatively official. That's all. That's just nice to have on the side. And finally, there's at the CS department, I've learned at Lund University, computer science, people are taught Git already first course that you have that and LaTeX and some Linux command line introduction. So if you're Lund University and you know Swedish, this is probably a good resource to have. And there's even a lab with some that has some exercises. So if you like exercises instead of trying out stuff, sort of playing around, then you can go over that as well. Yes. Now there's even more man pages that I also want to highlight. There's more man pages with Git. If they're in the man page number 7, then they're the more tutorial type things that more high level. So Git diff core, whatever, you know. There's because you can configure a lot of what Git does a lot, and of course the individual things like get status, get pull, get push, so on, they have their own individual man pages. So if you're wondering something about that particular command, you can definitely look into that. As with anything on Linux, if you're using it a lot, it makes sense to configure it. It will make your life easier. Okay, but that's I think with this you're set. You have everything you need to know to start using it in your projects, integrate this into project management, and yeah, I hope you have a nice time. I hope that now with this initial cost that I've put you through by watching this tutorial, now you're set for success and you won't lose time while you're actually working on the project. Good luck.